Okay, here we go, multiple angles. So this isn't new. What is new is we're going to look and see that we've got right here a 2t. And normally we have a t or an x or a theta. So that's the new thing for today. And what we're going to do is we're just going to ignore it for now. We're going to rewrite our problem. We are going to isolate sine. So we're going to subtract the 1. And then we're going to divide by 2. And once again, I realize we've got this 2t, right? This 2t right here. We're going to ignore it for now, and we're just going to say, oops, I didn't do that 1/2. When we divide both sides by 1/2, there we go. So we're going to stop and say, all right, where is sine equal to negative 1/2? And sine is equal to negative 1/2 down here at pi over 6. I'm sorry, pi over 6 is where sine is equal to 1/2. Negative 1/2 is when pi is down here, right? 11 pi over 6 and at 7 pi over 6. And so this is where it looks a little bit different. Normally we're like, oh, we're done, right? We're done. Our answers are 7 pi over 6 and 11 pi over 6. But not so fast. This is where our new part comes in. This is not what t equals. This is what 2t equals. So 2t equals 7 pi over 6. And 2t equals 11 pi over 6. So now we're going to solve for t, and that's going to be where our answer comes from. So normally when we get rid of a 2, we divide by 2, but it's weird when we're dividing a fraction by 2. So instead, let's multiply by the reciprocal, right? Multiplying by 1/2 does the same thing as dividing by 2. It just makes it easier when we're dealing with fractions. So there we go, the 2's are gone. We're going to multiply across. 7 pi times 1 is 7 pi, and 6 times 2 is 12. So here's one of our answers. Then we're going to do the same thing over here. We're going to go ahead and multiply both sides by 1/2. Does the same thing as dividing by 2. Get rid of the 2's, and then we're going to multiply across. 11 pi times 1 and 6 times 2. So here are our two answers. We're going to stop and remind ourselves, wait a second, what kind of interval do our answers, what's our range like? So our range is, it can be equal to 0 and all the way up to 2 pi, but not including 2 pi. So let's look at our answers. 7 pi over 12, that we're good. 11 pi over 12, we're good. So we've stayed within our range, and that we're good. All right, so we're going to continue on, and we're going to look at cotan of x over 2 plus 1 equals 0. And we're going to do the same thing. We're just going to go ahead and subtract 1. And then we're going to say we don't like cotan. And so we're going to take cotan. If cotan's negative 1, that's like negative 1 over 1. And if we flip it and change it to tan, we still get negative 1, don't we? So we're going to change this and say tan of x over 2 is equal to negative 1. All right, where is tan equal to negative 1? Ooh, I just stepped on my cord. Okay, so tan's equal to positive 1, right, at pi over 4. So tan is negative where? It's negative here at 7 pi over 4, and it's negative here at 3 pi over 4. So once again, those normally would be our answer, right? Our answers would be 3 pi over 4 and 7 pi over 4, but instead, x over 2 equals 3 pi over 4. And x over 2 equals 7 pi over 4. And so we're going to solve for that by getting rid of the 2. We're going to multiply both sides by 2. Sometimes it helps people if you put 2 over 1 and then you're just multiplying straight across. Yes, I see that we can simplify. I'm just going to multiply straight across so that it gives somebody an easy way to understand it. Obviously, you can simplify before you multiply. Then we're going to simplify the 6 and the 4, and that will be 3 pi over 2. So that's one of our answers. And then we're going to multiply by 2. And once again, I'll do it the same way. So we'll have 14 pi over 4, and we can simplify that. 7 pi over 2. That's our second answer. So let's make sure we stayed within our range. our range is from 0 to 4 pi, which is good because 7 pi over 2, that's 3.5 pi, right? So, but we're good. Both of our answers stayed in. Let's say this ranges from 0 to 2 pi. Well, then this 7 pi over 2 wouldn't fit in, and we couldn't put that in as an answer into delta math. So just be careful when you're doing delta math. All right, our very last one. And we're going to go ahead and add root 3, right? We're going to add root 3 of both sides. Now, once again, we know that we're dealing with something weird, right? The weird is that instead of just an x, we have pi x, and that's okay. We can deal with that. So let's divide both sides by 2, and then we say, where is sine equal to root 3 over 2? And sine is equal to root 3 over 2 down here, right, at pi over 6. Sine is also positive right here at 5 pi over 6. And so those are our two answers. Well, kind of answers. So pi x equals 5 pi over 6. And then we've got pi x equals pi over 6. So we're going to go ahead and get rid of the pi. We're going to do it the same way. We're going to multiply by the reciprocal. That it just makes it easier to deal with, right? Bam, bam, that gets rid of that. If we multiply straight across, we get 5 pi over 6 pi, and we can see that the pi's cancel out, and we just end up with 5 over 6, which is strange. We can deal with that. We're going to do the same thing over here. I'm kind of running out of space. Okay. Another way to do it is just to say the pi's cancel out, and then we've got 1/6. You could do it either way. So we've got 1/6 and 5/6, and that makes sense for why they gave us the parameters for our answer for the range, right, from 0 to 2. So let's make sure we're in that. 1/6 is and 5/6 is, right? And so we're good to go there. And that's that. I think you've got some delta math to do. And thanks for joining me. That was short and sweet.